Today we're going to be discussing DisCo, disentangled control for referring human dance generation in real world. This is by Tan Won out of Nanyang Technological University and others from Microsoft Azure. The basic premise of this paper is to take a reference image, which can be seen or unseen, split it into a foreground and background, then apply a pose and create a set of frames for a video. In this case, you can see the three key things this paper wants to achieve. One is faithfulness. So this is inputting a reference image here that is both foreground and background. So we're going to keep the same foreground character and have a background image the same. We're going to apply a target pose. The output will be a series of frames that matches the pose for this character. And it should be faithful to the same foreground, background, and pose. The second item is that it should be generalizable. So in this case, there's an unseen foreground and background. So this person and the background have never been seen during the training set. It has been an unseen pose, so none of these poses were used during the training set. And outcome should be a high quality series of images that can be composited into frames of a video. You see that the woman appears to be similar, the background is similar, and the pose matches. The last one is compositionality. In this case, we have a reference image here from source A, and you see we have cut out the background. So this is a single individual. It's going to be our foreground character. Then for each frame, in this case, you're putting in a different background here. You can see each is different, and a different pose. And the four frames on the right each have the same character. It is faithful to her representation as far as she looks similar to the reference image, reference foreground image. The backgrounds match each of the backgrounds that were put in as the four sources, and the pose matches the four poses for these images. Now, of course, this is not going to be useful as is for video. However, what this implies is you could take a new background from a different character or a different image set of some type and apply it onto the person that you want to put into the video. Now, you'll note all these videos were trained on TikTok characters in which you have roughly this size where there's a person in mid-frame of the camera doing some kind of dance. This generalizes to other items, but most likely it needs to have one character per frame. It does not generalize as is to multiple characters, and this is something that was discussed as a potential expansion of the project. Now let's discuss the architecture. If we look at the left, there are several different blocks. The main backbone is composed of stable diffusion. It has it's a unit with a series of resonant blocks and attention blocks. And it scales down to a middle latent layer in the middle of the U. The inputs into this are clip encoder. Now, normal for stable diffusion, this would come from text, but in this case, it will come from an image. Same type of situation though. That then gets added into the appropriate blocks within the unit. Separately, there is a background image that gets fed separately. So in this case, the image that goes into the clip is only the foreground image. Now this is separated from the background by something like SAM, segment anything model. It can be done by any other method, but it does require that by some other method not discussed here or not expanded on here, that it is split into the two pieces. The background image is then fed through an encoder, which is just pre-trained, goes into a control net, and that control net then feeds the middle latent block along with the upnet, UNet up portion. Finally, the pose is similar. It gets put through a pose encoder, pose control net, and it goes into the middle and the UNet up portion. Now, training this all at one time is going to be difficult, specifically because things will start to become coupled between the foreground, the background, and the pose, and may not lead to complete disentanglement. So to get around that, we do something slightly different. If you look at the right here, we do some Human attribute pre-training. In this case, we take images, we break them into the foreground and background, keep them in the same Stable Diffusion backbone, and we train a couple of items. First of all, we train the background the background control net, and we train the attention layers here. It was empirically found that the best results were from letting the attention blocks release and be trained while keeping the ResNet blocks fixed. As the clip encoder as the training proceeds, these sections are all trained, but you'll note there is no pose. The pose is not present in this case, and what this allows is this background control net to be completely independently trained from the pose section and only separate out the foreground and the background. The next section that is now done after you have this is you go back to the main disentangled architecture here and use whatever pre-training you had from the right, the human attribute pre-training, and use those as the weight initializations for the background control net and the stable diffusion net here. By doing this, and then allowing you to do the training, you train mainly the pose encoder and pose control net. Now, these other items are trained, so you will get some variation there, or you will get some fine tuning there. However, because they've been locked down, because they have been pre-trained by using this human attribute pre-training described on the right, these are fairly well set, and you won't see as much variation as you continue to do your training against the target image, which is mainly to match the pose. As far as what data you use here, the data is videos. So you take the first frame of the video, make that your foreground and your background image, and then you use every frame to create the different poses and train in that way by using the videos. Now, the one thing you'll note on the right, when we did the human pre-training, we didn't have to use videos. We were able to use a series of static images, and that was highly advantageous because there are so many more static images rather than videos. So this allows very large scale human image training to separate the foreground and background images, and allows you to have many fewer variations many fewer videos in your training set. I'm not going to go into all the mathematical results as far as the quality. However, it's enough to say that it's quite good, especially compared to the dream pose, which is one of their main things they were comparing against. This is an example of what can ultimately be achieved. You can see the videos here at the bottom. There's 5 different reference humans and backgrounds with the same target pose in each of these, and you see the dance goes quite well. There is temporal consistency between, as a general rule. There's a few glitches. Overall, DisCo did a very good job of disentangling the foreground, background, and pose in order to produce dance videos. Has good control. There is a small amount of glitching over time. However, this is one of the areas that the authors identified as a future area of study. Hopefully everybody liked this video. If you did, please hit the like button and subscribe. Thank you.